Okay, now I'm asked the other question that you skipped past again. Einstein said that all terrestrial experiments attempting to detect the motion of the Earth have resulted in a negative result, and prior to relativity being put forward, it was difficult to become reconciled to this result. So what did relativity do to reconcile those negative results?
I don't know. Don't care. Austin, we can measure all these things externally. So like I said, the best you do is you take one thing away of the measurement of the rotation of the Earth and the orbit of the Earth around the sun. There's other ways to do these things, and you don't move your position forward at all. You don't provide supporting evidence for your position, Austin. Well, why don't you actually try to go for evidence supporting your... Oh, I know why.
Well, this is the thing, right? So you're kind of being disingenuous because the whole position that you hold is that the evidence does support a stationary Earth.
No, it doesn't.
But literally your position is that the evidence supports that the sun moves around the Earth, that the Earth is stationary, but that since relativity is true...
No, that's not my position.
No, this is objective.
This is objectively you strawmanning me.
Estimated difference between these two times is exceedingly small, talking about the two lights, one going with and one going against the motion of the Earth. Michelson and Morley performed an experiment involving interference in which this difference should have been clearly detectable. So he's saying even though when you shoot the laser, you remember when their whole argument was, oh, Lorentz contraction would have been 1/5000th the width of a hair or whatever, right? Yeah, that's the point. That's the point. Einstein's explaining here in his paper that he's like, although if you shot light with the motion of the Earth going 20 miles a second around the sun and then against it, the difference would be really small. But Michelson and Morley developed such an impressive apparatus that it would be clearly detectable with their apparatus, right? Okay. So, although the estimated difference between these two times is exceedingly small, Michelson and Morley performed an experiment involving interference in which this difference should have been clearly detectable, but the experiment gave a negative results, a fact very perplexing to physicists. Lorentz and Fitzgerald rescued the theory from this difficulty by assuming that the motion of the body relative to the ether produces a contraction of the body in the direction of motion, the amount of contraction being just sufficient to compensate for the difference in the time mentioned above. Comparison with the discussion in section 11 shows that also from the standpoint of the theory of relativity, this solution of the difficulty was the right one, meaning the solution to the difficulty of the negative results was the right one from the standpoint of relativity. Again, it explains here. They said that the reason you got the negative result was because of a contraction. And he explains here that also from the standpoint of relativity, the same answer was the right one. But on the basis of the theory of relativity, the method of interpretation is incomparably more satisfactory. According to the theory, there is no such thing as a specially favored unique coordinate system to occasion the introduction of the ether idea, and hence there can be no ether drift, nor any experiment with which to demonstrate it. Here the contraction of moving bodies follows from the two fundamental principles of the theory, without the introduction of particular hypotheses. And as the prime factor involved in this contraction, we find not the motion in itself, to which we cannot attach any meaning, but the motion with respect to the body of reference chosen in the particular case in point. Thus, for a coordinate system moving with the Earth, the mirror system of Michelson and Morley is not shortened, but it is shortened for a coordinate system which is at rest relatively to the sun. Okay, so it did physically shorten, okay, but we are in the frame of reference that shortened with it, so we couldn't tell that it shortened. So it didn't shorten for us because we shortened with it. Now, I've been saying this to them the whole time. This is what happened. He took Lorentz contraction from Lorentz, threw out the ether, kept the same mechanism, and applied it to the arm, but made up a different interpretation and didn't actually fully introduce a mechanism for the result. Again, he says it in his own words. It's insane to me. I hope that you guys followed that.
That's not my position.
No. Relativity says that although the results and the evidence appears to show us that the Earth is stationary, it's actually just an illusion.
Whatever. It doesn't help you. It doesn't move you forward.
So you agree with that, though, right?
No, it does not appear to be stationary. It is a negative result at best. It is we don't have a result. It is nothing useful. That's what that means, Austin.
So we tried to detect motion, and it was a negative result, which is what would happen if there was no motion. But the best that it gives us is that we know nothing. Wow.
It doesn't mean that it is stationary. It doesn't mean that it's evidence for stationary. It is evidence for nothingness at best.
That is so disingenuous. If the Earth was stationary, would we get a negative result? Yes or no?
If the Earth was stationary or rotating, we would get a negative result.
Now you're just begging the question of the ad hoc explanation that tried to explain why the results were negative.
Neither. It's nothing at best.
In public, he has to fake his belief in public.
This is such a good point to learn here. Okay, this is the actual globe's position. The relativity came in and put their little ad hoc make stuff up cape on, and said, "Oh, if the Earth was stationary, this is what we get. If the Earth was moving, this is what we get. Let's change it. Move the wand around. Okay, now according to relativity, if the Earth was in motion, we would get the same thing as if it was stationary." He just admitted it. Would we get a negative result? Yes or no?
If the Earth was stationary or rotating, we would get a negative result.
Now thanks for playing. Just begging the question of the ad hoc explanation that tried to explain why the results were negative.
Neither. It's nothing at best.
In public, he has to fake his belief in public, and that's why he talks like this. He may not be being disingenuous. He wants people to believe he actually believes this shit. So
do you see like what he's doing, right? He set up this narrative where even though all the evidence shows that the Earth is stationary, he's claiming it doesn't. He's claiming that we can't use that evidence.
It definitely doesn't show that.
It literally does. Like, that's what it
really
is.
It literally is a negative result, as Einstein said. A negative result
because he attempted to detect the motion, but got a negative result, which is what you would get if the Earth wasn't in motion.
Why do you pick this specific part of what Einstein said?
Because I found that you guys are so dishonest. Now here comes the other Globers trying to tag on me, like tag team on me, right? It's super funny.
Why do you pick this specific part of what Einstein said?
Because I found that you guys are so dishonest, you can't even talk about this.
He's with Robert Sungenis, is what he is.
No. Now he can just straw man me, right? But the reason, Platypus, is because
you guys bringing up geocentrism. That's his thing.
But I love it. I wouldn't even want Mctoon to be over here with us trying to figure out the true nature of the Earth, right? I don't do this to wake up anti-flat Earthers that have impulse control issues and constantly interrupt me like he's doing right now. I do this for people that are new to the subject, and I get many emails that say, "Wow, like it wasn't really you; it was how dishonest they were being that made me decide to look into it." And that's why I talk about this, because I found that unfortunately no baller can even admit this stuff.
Pat yourself on the back.
Well, it's kind of like an intellectual honesty litmus test, right? At the beginning, that's what we're kind of building up to, I think.
Yeah, and it should be like a 5-second thing, and then we get into the nitty-gritty of the conversation. But I found out that it actually turns into hour, 2 hour, 3 hour long debates.
Okay. Any evidence supporting your claim? No. Got it. You never do, Austin. You never even try. And you think that a negative result of an experiment is somehow evidence for your position. It's not. It's a result of nothingness. You can draw no conclusions from a negative result from Michelson Morley.
It's just so dishonest.
This is so dishonest. Oh, yeah, you just don't understand. You're out of your league. Come on, Austin. Stop patting yourself on the back. Stop puffing up your chest. Show some evidence.
Wait, watch. This is what he couldn't. He can't.
Look how mad he is right now, bro.
Oh, yeah, you just don't understand. You're out of your league. Come on, Austin. Stop patting yourself on the back. Stop puffing up your chest. Show some evidence.
Wait, watch. This is what he couldn't. He
can't even. I'm so much smarter than him. I'm Austin. I'm so smart. You're out of my league, everybody. I'm way smarter than everybody. Because Austin, that's what you do constantly. If you spend half your time
than everybody,
you do. You constantly say you have a high IQ.
Can I talk yet?
You went around the country yelling at people on streets that you have a higher IQ than all of them.
But the only reason I ever brought my IQ up on the streets is because people would say, "You're such an idiot." They would actually say, "You must have less than an 80 IQ. You must have dropped out of high school. You're a moron." So I would say, "Actually, I have a pretty high IQ. So if we can throw that out the window, you want to talk about the actual subject." But this is the point, right? I don't even think you're stupid. I just think that dishonesty renders a person's position stupid. And I'm trying to get you to be honest. And if you could just be honest, that'd be cool. Because if I asked you, well, then what would you suggest we do to show that the Earth is stationary? You would say, I don't know, that's your job. And the truth is that if someone's competent and honest, they would know that if the Earth is stationary, then any attempt to detect motion of the Earth would be negative. You don't measure stationary. That's stupid.
You can measure stationary. Of course you can.
How so?
Rotation is absolute. Linear motion is relative, but rotation is absolute, Austin.
How do you measure stationary?
Measure for rotation, and if you get none, then it's stationary.
Oh my gosh, he came back and said, I said, well, then how do you measure stationary? He said, attempt to measure for rotation, and if you get none, then it's stationary. Bro, orbit is rotation around the sun. We attempted to measure that, and we got nothing. So it's stationary, according to McClooneytoon. Sidereal rotation measurements don't help us determine this because we know that the sky looks like it's moving. So either the sky has movement within it, or the Earth is moving and the sky is actually stationary and just looks like it's moving, and we're moving but we can't feel it. Okay? That's the only way. It's one of those two, right? So that doesn't... We need another test of movement. You claim it's orbiting. He said that a negative result is not evidence of stationary. And then when asked how you would get measurement of stationary, he ridiculed me and said, yeah, you can measure stationary, ha ha ha. And his example was you attempt to detect rotation, and if you don't detect it, then it's stationary. It's hilarious, bro.
So when we measure for orbit, we get none.
Oh, I said rotation, not orbit.
Orbit is a rotation.
Yeah.
Yeah, thanks for playing.
Yeah. So the reason why
we get none
for rotation is absolute, Austin.
Yo, I gotta put it back on normal speed for a second.
Measure stationary. That's stupid.
You can measure stationary. Of course you can.
How so?
Rotation is absolute. Linear motion is relative, but rotation is absolute, Austin.
How do you measure stationary?
Measure for rotation, and if you get none, then it's stationary.
So when we measure for orbit, we get none.
Oh, I said rotation, not orbit.
Orbit is a rotation.
Yeah.
Yeah, thanks for playing.
Yeah. So the reason why...
I'm just so done right now, bro.